Logarithmic functions. I'm Anil Kumar, and in this video we'll capture the key features which are required to sketch graph of the inverse of each exponential function given here. We have two exponential functions. They're kind of related. The first one is f of x equals to 2 to the power of x, and then we have g of x equals to half to the power of x. I already have a video which explains how to do this. Link for that video will be given in this video itself. Now you can pause the video, answer this question, and then look into the suggestion. That will help you to review the concepts learned about logarithmic functions. Now when we say sketch graph of inverse of an exponential function, then the graph which you get is actually a logarithmic function. Inverse of an exponential function is logarithmic function. So inverse, let's write it as y equals to log to the base 2 of x. The exponential function here has a base of 2, right? So log function will also have a base of 2, and the inverse will be log of 2x. You can also write this as f inverse of x will be log 2x. So that is a function which we are going to sketch. Now there are a couple of ways to do it. One of them is you can consider key points of 2 to the power of x. So the key points for 2 to the power of x are what? Well, we can say that the key points are, let me start from 0 and then list few. Anything to the power of 0 is always 1, correct? And anything to the power of 1 is the base itself, right? So that's a good point to start. And then you can take 2 square is 4. These are good points on the positive side. And on the negative side, we could take minus 1. So anything to the power of minus 1 will give me half, right? 1 over 2. And for, let's say, minus 2, we'll get 1 over 4. So these are good points to take. Another thing is, when x is very large, then the exponential function will be very large. And when x is approaching infinity, exponential function will approach 0, correct? So these are the other, that is the end behavior. So these are the key points, and then we'll also consider end behavior. So end behavior, what I mean is, when x is approaching negative infinity, then y approaches 0. When x approaches positive infinity, y approaches positive infinity. So these are the key points for 2 to the power of x, correct? Now how about the inverse? For inverse, we have to flip these points and get the real points, correct? So let me just put it in another box, and this time we'll do f inverse of x, which for us is log to the base 2x, correct? Now the key points can be used the same point but flipped, right? So we could write those points as 1 over 4 minus 2, half minus 1, right? 1, 0, 2, 1, 4, 2. So kind of easy, right? As far as end behavior, that also flips. See that? End behavior also flips. So instead of saying x approaches negative infinity, we say, well, when x approaches 0, y approaches negative infinity. Okay, so we just flip this. So as x approaches 0, y approaches negative infinity. As x approaches positive infinity, y approaches positive infinity, right? So that gives us the key points to sketch this very function, right? I'm doing this for 2 to the power of x. You can do the similar calculations for the other function. So that way I get more space to graph here. So what I will do here is kind of sketch a small graph. Okay, let me use the whole space. So if I'm sketching 2 to the power of x, I'll get a function which is kind of like this. These are all rough sketches. You can use a graph paper and then do a neat job. And to flip it, we have to draw a line which is y equals to x, correct? So this is, let's say, y equals to x. And the function which we have drawn here is 2 to the power of x. We say this is 1, and at 1, let's say this point is 2 and this is 1, right? So that is good enough. And let's say this is half. Okay, that's fine. To sketch the reciprocal, to sketch The inverse, we have to flip it on this side, correct? So this point will come here, and this is approaching x here. As we approach 0, y will approach negative infinity. So we have kind of like this. That becomes our log 2x. Is that okay? So that is how you're going to sketch the graph of the function. You can use these points or any of those methods which you've learned so far. Now, as far as g of x equals to half to the power of x is concerned, I recommend you to make a table of values just as we did for different values of x from -2, -1, 0, 1 and 2, right? And then do the needful. What I will do here is kind of sketch that function also, superimpose it on the same graph paper. Looking for right combination of colors now. So let's use a light color for the exponential function, which is half to the power of x. So anyway, anything to the power of 0 is always 1, and this could be a graph which is kind of going, let me just go like this on this side, and this is going like this. This is g of x for us, okay, which is half to the power of x. Now, if I have to sketch inverse of this function, then how should it look like? Think about it. You can pause the video and then do it, right? So it will also go through this point. That's very clear, and that is invariant. That helps. And what we can do is we can just flip it like this. Is that okay? And here this is going like this. So it is going to be a large value, right? So it's kind of like this. Do you see that part? So that is how it is going to be. And how can we write this? We could write this as log of half x. Do you see that? So log of half x is the inverse of half to the power of x. Do you understand? So what is g inverse of x? It is log of half x. Correct? Now, if you notice, these two graphs, they are related. Can you tell me what is the relation between these two graphs? And that is a question for you. So the question for you is, how are log of 2x and log of half x related? Now that is a very important question which you should be answering at the end of this video. Okay, have a good look at these two graphs. There you are. How are they related? Well, so answer this question, and I hope that helps you to completely understand the concept of logarithmic functions, their relation with exponential functions. Just remember that inverse of an exponential function is a logarithmic function. Their bases remain same, but they have to be reflected on the line y equals to x. That helps to capture all these things and move forward. I hope that helps. I'm Anil Kumar. You can subscribe to my videos and learn a lot. Thank you and all the best.